Section 7.7 Key transposition. Sometimes it is preferable to transpose a message one block at a time. The best choice for transposing blocks is key transposition. Write the numerical key above the characters of the message, then move each character to the position indicated by its key number. In this example, the block size is 8, and the numeric key is 41278563. The key number for the first letter, R, is 4, so move the R to the 4th position in the block. The key number for the second letter, U, is 1, so move the U to the 1st position in the block, and so forth. The key transposition may be used on the plain text, the ciphertext, or both. A key transposition by itself is weak. The key transposition is rated 1 to 3, depending on the block size. Let's take a deeper look at transpositions. In mathematics, transpositions are called permutations. Here is an example. I have used the hexadecimal digits A, B, and C to denote the numbers 10, 11, and 12. In a cipher, these numbers will represent the bits, letters, or other units that are being permuted. The top line is standard. It represents the original order before the permutation. The second line is the permuted order. Later in this section, the second line will be used to describe permutations. In this permutation, the number in position 1 moves to position 4. The number in position 4 moves to position 7. The number in position 7 moves to position 12. The number in position 12 moves to position 3. And the number in position 3 moves to position 1, completing the cycle 1 to 4 to 7 to C to 3 to 1. The cycle can be represented as 1, 4, 7, 12, 3. The first number that is not in this cycle is 2. Starting from position 2, we find the cycle 2 to A to 6 to 9 to B to 8 to 5 to 2, which can be represented as 2, 10, 6, 9, 11, 8, 5. The whole permutation can then be expressed as brackets 1, 4, 7, 12, 3, brackets 2, 10, 6, 9, 11, 8, 5. These two cycles have periods of 5 and 7 respectively, so this permutation has a period of 35. That is, if you kept applying this transposition to a block of 12 letters, it would produce 35 different permutations of the letters, and the 36th permutation would be the same as the original plain text. Suppose that you wanted to produce a strong block transposition cipher, one where every block has a different transposition. Applying the previous transposition a different number of times for each block would not be adequate because it repeats every 35 cycles. This problem can be overcome by using two different permutations and alternating. Let the two transpositions be A and B. If A and B are suitably chosen, then you can generate a huge number of transpositions. A, B, AA, AB, BA, BB, AAA, AAB, ABA, that are all different. This is where understanding the cycle structure of the permutations becomes important. Suppose that you chose the permutations brackets 1, 4, 7, 12, 3, brackets 2, 10, 6, 9, 11, 8, 5, and brackets 1, 4, 3, 12, 7, brackets 2, 10, 9, 6, 5, 11, 8. These two permutations partition the block of 12 units the same way, namely square brackets 1, 3, 5, 7, 12 and square brackets 2, 5, 6, 8, 9, 10, 11. When you alternate the two permutations repeatedly, the square brackets 1, 3, 4, 7, 12 partition will get permuted separately from the square brackets 2, 5, 6, 8, 9, 10, 11 partition. That is, there is no interaction between the two sets of numbers. To get a long period, each cycle of the second permutation should overlap each cycle of the first permutation as much as possible. Here is a suitable set of permutations. This transposition cipher is rated 3. It can be solved simply by trying all of the 12 factorial possible permutations in the first block. This is only 4.79 times 10 to the power 8. For each permutation that produces reasonable text for the first block, Emily can try each of the 12 factorial permutations for the second block. In practice, this takes far fewer than 12 factorials squared, which equals 2.29 times 10 to the 17 tries, because just looking at the first 3 or 4 characters of the block can eliminate many implausible combinations. In fact, it is feasible to solve this cipher by hand methods. The difficulty increases slowly with larger block sizes. There are several ways to increase the security of a key transposition. One way is to overlap the blocks. If the block size is 16, for example, instead of starting the blocks at positions 1, 17, 33 in the message, start the blocks at positions 1, 9, 17, 25, 33. That way, each block overlaps 8 units with the block before and 8 units with the block after. The last 8 units of the message may be combined with the first 8 units to form a wraparound block. This cipher is rated 4. The amount of overlap can be variable. If the current block starts at position P and the block length is L, the next block can begin anywhere from position P plus 1 to position P plus L. This cipher is rated 5. If 2 different transpositions are used and chosen randomly, the rating increases to 7. A second way to strengthen a block transposition cipher is by composing the permutations. If T and U are transpositions, then the composition of T and U, denoted TU, is formed by first performing transposition U and then performing T. The resulting transposition is the same as using T to transpose U and then transposing the text using the resulting transposition. Let's try an example. Suppose T is 419628573 and U is 385917462. Since U is a block of 10 characters, you can use T to transpose U the same way you would use T to transpose a 10-letter word. Write T on the top line to use as the transposition key, and write U on the second line as the text being transposed. The first digit of the result is the number below the digit 1 in the key, namely 8, C shading. The second digit of the result is the digit below 2 in the key, namely 1, and so forth. Using T to permute U gives 81234965.